buying the products on the e-commerce, what really the interactions happens? The first of all, these backend services need to be exposed as an APIs, and this will be done by the API team, which is the internal development team. Once these APIs are available, these would be analyzed by the developers, the team who develops the apps, and those apps would be available on the different devices, mobile devices, or any of the smart devices, or even the traditional browser or over the laptop, right? And then the customer can access those apps. So there are multiple points of engagements. And that brings the challenge from the security perspective as well. Now, to be ensured the whole transaction is secure, we need to ensure each point of engagement there is a required security has been enabled or not. For example, in the context of the APIs, yes, we need to ensure the OAuth2, quota, spike arrest. In the similar way, when the app developer, who are the third party, when they are accessing these APIs, they have the right RBAC mechanism. And when the apps are accessing those APIs, again, there has to be the right API key or the TLS, and the similar way for the customers. So that's what one of the end-to-end security. Another requirement, what we have seen for many of the enterprise customers, they have the requirement of PCI, payment card industry, HIPAA, mainly for the health, and many others. So just to emphasize the point, APG platform is certified across all these requirements. So now what you see, right, this is the horizontal view, the way we see it across the point of engagement. Now the next slide is for each of these specific point of engagement, what's really the vertical? And when we say the vertical, what really I meant by the security protections across the OSI layer. So in terms of the OSI layer, if the network level security, then is there a mechanism to whitelist or blacklist an IP address? And this may become important if you are doing the B2B use case. So you know these requests will come only from this IP, and you either want to whitelist those IP addresses only. On the transport layer, TLS, so it may require one-way TLS, two-way TLS. APG platform has the supports of the both. And when we say the TLS, it's from the client, the device, till the APGS, and then from APGS to the backend services. So the both need to be fully on the TLS part. On the API level, then there are multiple other policies, like you have the OAuth, different grant types, JOT, API key, SAML, and then the threat protection policies. And last but not the least, if any user who is accessing the platform, they should have the right access privileges, what operations they can do. So this is more like, think like the vertical dimensions, and the previous one was the horizontal one. In the context of the APG platform, we have more than 50 plus policies, out of the box policies, and some of those policies you can see on the right hand side screen. So that's what was the high level overview, what really the security means in the context of the APG platform, and what really we mean by each points of engagement. So let's start on the lab point. You can see the links. We need to log in with the APG platform. And the second one is on the API lab, where the API labs are available. So this would be available already as part of the resources. So please access these links, because we will follow up the API jam materials here. Now let's start with the first type of policies when we talk about the threat protection policies, right? So the first rule is to protect yourself. So our systems should remain up. Our backend services should remain available, and they should be able to respond. In the outside world, and there could be multiple type of attacks. They can be denial of service attack. Someone can send via the high traffic. So let's say if your backend services has the capacity to manage 100 requests per minute, and if I send the 100 requests per second, and if there is no proper queuing mechanism or the other protections, the backend service will come down. So that's one of the denial of service attack. The second one is, I will send you the limited request, like maybe let's say the 100 requests per minute. So I will send you the 100 requests per minute in that limit, but I will send you very hefty payload. And that's what comes of either the XML or the JSON. And that, because it consumes the memory on your backend service, so there's a good possibility it may bring down the server or backend services. And the third attack, if I'm aware of if your backend services has the, let's say, the SQL database, I can send the SQL injection attack, like something like the delete star command, something like that. And if it goes through all the way, will bring down the services again. So there are different type of attacks which are happening, and we need to ensure our backend services are protected, and the APIs are the best place to make that happen. Now, for our labs, we will emphasize on the first one, how we can ensure our APIs have protected on the denial of service attack. And so we will be implementing the spike arrest. So before we implement the spike arrest, yesterday lab, on the day 2, the people who have joined, they have done the lab which is on the quota policy. So now the point of questions would be, okay, so what's the difference between the two? Through the quota policy, I can again limit the number. I can say, okay, 100 requests per minute, and the quota policy will ensure that. So what really the spike arrest brings the value? So just to highlight the point, these two policies actually works in a complement way. They are doing two distinct things. Where the quota policy is for the purpose of how many requests can be made by this app. So let's say you're in the B2B scenario, how many requests can be made by this business app or this business partner? So this request will be like 100 requests per minute, 100 requests per hour. So it's a number of requests in a time interval per time unit. The purpose of the spike arrest is not to ensure the quota, is to do the protection of the backend service. So if I bring the points here, my backend services can have the capacity of 100 requests per minute. It can serve the 100 requests in 1 minute. What will happen if all the 100 requests comes to the backend service in the very first second? It may be the case the backend service may not be able to handle that. And that's where the spike arrest comes into the picture. And the way it has been implemented is, it's based on the interval. So let's say, if I take up the example of, like in this scenario, we have given 10 per second. What really this mean is, in the quota policy, this would mean 10 requests per second. But in the context of the spike arrest, this would be transformed into the 1 request per 100 milliseconds. So what happened behind the scene? Spike arrest find out how much time interval is there for the 1 request, right? So this 10 requests per second will become 1 every 100 milliseconds. And if I take up the request of the 60 requests per minute, for the quota policy, it's a 60 requests per minute. But from the spike arrest, that means is 1 request per second, right? So if I just further explain on this one, so now these are the interval of the 100 milliseconds. And 1 request within this interval is allowed. So if every 100 milliseconds, one request is okay. But on the second scenario, if you notice, we got the first request, it's fine. It will go ahead to the backend service. But if within the 100 milliseconds, we got the second request, that's being rejected by the spike arrest. So what's really happening is spike arrest is providing the protection of avoiding the mini spikes, right? So as a best practice, we implement what we suggest. First, protect your backend service. That means the spike arrest will come first. And then after that, you implement the quota policy and you find out whether this partner or this app can make these many requests or not. So it's a spike arrest followed by the quota policy. That's the way it's being recommended on the FPGA Edge platform. So that's the point here. You first implement the spike arrest policy, and then you implement the quota policies. It's one after another on that. That's the best practice. So with that, let's move on to the lab. You can see this is the link. So let's move on to that. Let me first, if I go on to this is our lab page. I'm moving into the lab one. So it's a simple, we will follow the same steps like we have done in the day one. If you already have a proxy, that's good. Otherwise, for the folks who are joining on this day 3 only and they don't have the access, there is a proxy bundle which can be downloaded. So this is the API proxy bundle. So let me just demonstrate that. And I'm already logged into the FPGA platform. I'm hoping you all as well. So let me go into the proxy wizard. You people can also start the lab. I'm uploading the bundle. Let me upload the bundle, the one which I just downloaded. It's verifying this proxy is not there. And now it's reading the bundle, it's parsing the bundle, and it has created the proxy. Right? So once the proxy has been created, this is the screen what you see. Just to give you the high level view, this is the revision one. This is the base path of the proxy. And this is the target endpoint. And if you see the target endpoint of this service is, which has been mentioned here. At this moment, if you notice on the deployment, I can see there are 3 environments in my organizations. In most of your organizations, as you're using the trial one, there would be 2 environments. So let me deploy onto the test. So now if you notice, once it's deployed, it gives me the URL where this proxy is available and accessible from the outside. So let me pick up by default it's deploying on the HTTP and the HTTPS. It's configurable. So one is this link, I can use the Postman, or what we can do is for this request, because we are making the GET request only, I can go onto the trace. You people already have seen this tool. I'm going to start this one, start. And this already showing me the path. What really I need to do is I need to add the resource name, right? And this was one of the reasons. Some of the questions from yesterday, they were saying they are getting the 503. So you need to add the right resource name there, because by default that home path, the base path, right, it should not return anything. So you need to specify the resource. Once you do that, you won't get the 503. So on this one, right, we got the response in 320 milliseconds, and this is the default proxy what we have implemented, right? And you may have seen it display the individual steps. This factory symbol, this represents the target service, right? So let me stop the trace. What I'm doing now is I'm going to the develop tab. As you may have noticed, already the proxy bundle is there. What we'll do, we'll add the spike arrest policy. If I click onto the plus steps, there are many policies available on the left-hand side, and these are what the out-of-the-box policies available on the APAC Edge platform. We are looking for the spike arrest, so let me click on that, and let me add it. If you notice, this is the default configurations on it. Just for our demonstration purpose, you can give any values. Let me give the 2 requests per minute so that it's easier to demonstrate on that side. And let me save this proxy. Again, just to ensure, yes, it's available on the test. Let's again go on to the trace, and let's start the trace sessions again. Right. So this is the path. This is our API and the resource path on that. And let me send the request. So it's coming on to the trace. So if you notice, it has given me the 2 successful requests. And you can notice the request is going to all the way to the backend. And if I go to the 3rd request, this symbol, this highlights, okay, this policy has been failed, or this policy does not fulfill the request, whatever the value has been configured. And because of that reason, it doesn't go further. If you notice here, there's no factory symbol, which you can see it in the successful request, and the factory represents the backend service. The request is getting terminated at that point, and then APG platform is sending the default message. And if you notice, you would be getting this message, something like this. And this has been added by the APG platform. Definitely, you can customize it based on the requirement of your enterprise. Yeah? So this way we can implement the spike arrest policy. If you want to use from the Postman, again, we can do the similar way. Let me put this request, what we are making. I'm going to this is my request. If I make this request, again, it will be successful, and then this is the violation. So I'm getting the 429. 429 is for too many requests. Again, you can configure the message, or you can configure the HTTP code as well. With that, let me give you guys some time to run this lab, and I will be mute during this time. After 5 to 7 minutes, we will continue the lab next step on this one. So I'm on mute now, but if you people have any questions, please feel free to use the Q&A. My colleagues are there to help you out. I hope you may have been able to complete the lab one. It was the sort of the repetition of the labs which were being done earlier with the addition of adding the spike arrest policy. So let's move into the OAuth, which is the de facto standard when we talk about the APIs for providing the security, mainly for the authorization purpose. Just to give the background, OAuth started with the OAuth 1.0 protocol, but that never goes into the production. None of the enterprises use that. Then they came with the 1.0A, which was being used by many of the enterprise, and the Twitter was using it. And then the OAuth 2.0. This OAuth 2.0, the current version of this is being, like I mentioned, it's a de facto standard and is being used in mostly all the APIs. Now the OAuth protocol, it's not as we have noticed, there are multiple point of engagements. So that means even a single OAuth interaction is not possible to fulfill that requirement. And that's the reason they came with the 4 different grant types. So just to give an idea, the client credentials is being used for the B2B scenario. So if the one business want to access the another business, so let's say an enterprise, if I take up the e-commerce examples, right, e-commerce site, and they have to talk to the other services for the logistic point of view, it's a B2B scenario. So the client credential is a good enough grant type to implement that approach there. The resource owner password credentials, this is more on the B2C scenario, business to consumer. So let's say when I am accessing the e-commerce site via their mobile app, so I am their customer, but because this app is being developed by that e-commerce site itself, so we can use the resource owner password credential grant types. And you must have seen the authorization code where, let's say, if you want to validate your authenticacy via the Google ID, so many of the sites put the move into the Google ID where you enter the credentials. So the credentials are being managed by the Google IDM, but they say, okay, he's the valid user and pass on the name or the other required information, but the credentials are with the Google ID. So in that case, the authorization code. And the similar line, implicit is being used when you're using on the scripting base, like the JavaScript on a browser. So you use the implicit one. And just to give you the more information on this point, so just to put the on the right-hand side, client credential, in terms of the complexity, this is the simplest one. And then the complexity keep increasing as we move forward to the other grant types. So just to summarize the point here, if you're looking for the B2B, client credentials. If you're looking for the B2C, where the app is a trusted one, that means the app is owned by the same backend service, then go with the password credentials. If the app and the credentials are being managed by 2 different parties, go with the authorization code. And if you're on the browser app with the JavaScript, go with the implicit one. So those are the high-level guidelines, which grant type need to be used in what scenario. Now, in the context of the overall OAuth 2, right, it's not only about validating the credentials, validating the API key or the secret, and giving the token, right, and verifying the token. There are many other aspects comes into the picture as well. Like, apart from the grant types, what sort of the scopes? It's a valid API, but can it only retrieve the data, or can it also create the data as well? So you can have those sort of scopes, read-only or the complete access. The token which have been generated, you can customize, you can add some attribute information onto that. What about if your token has been hacked, or you think there is a chances of that, and you want to explicit revoke the token? So by default, the token comes with a TTN, which you specify at the generation time. But in those scenarios, there may be requirement when you want to explicitly revoke. So that functionality should be there on any API management platform. And the similar way, what about if the API key has been hacked? Yesterday or day before, one of the participants has mentioned what happens if the API key has been hacked. So yes, you can revoke those API key and you can generate a new API key without having any impact on the other traffic, whatever the traffic is going for. As soon as you start using the new key, you can your operations will become. In fact, this is one of the best practice where we say API key, there should be a rotations on the regular basis to rotate the API key. Now what about, okay, I can revoke the token, I can rotate the API key, but what about if I only want to revoke the token for some specific user or some specific ID, not for the other, right? So there should be mechanism on that. And in this complex enterprise where we are using so many systems, each system has their own mechanisms and they have their own token. Is there an ability, whatever the management platform, API management platform is using to use the third-party tokens? So when we think about in the implementation of the OAuth2, these all aspects start becoming critical and important, and we need to ensure they are being configured or they are being available. Okay? With that, so that was the high-level overview on this one. What we'll do now, we'll move into the lab. So this lab is quite longer than the previous lab. In fact, this lab, in my opinion, can be divided into 4 different parts. So this lab will take more time. There are 4 distinct parts are there. The first one is we need to now have an endpoint or an API endpoint which generates the token, right? That's the first part. The second part is the API what we have, API proxy what we have, where we have done the spike rest, we need to enable or enforce the token verification mechanism on that. So we need to protect that API with the token verification mechanism. The third point, once these 2 facilities are being done, in the third part, we will create an API product. We will create an app so that we can get the API key and the secret. And by using that, we will generate the token, right? So that's the third part. We will create an API product and we'll create the app and we'll get the API key and the secret. In the part 4, we will test it out. We will use this API key and the secret to obtain the token, and then we'll use the token to access the API. Yeah? So this is the API link. I will also let me demonstrate on that. So let me go into the lab 2 now. If I go into the lab 2, so we will follow the same steps. We will now, there is a, I'm just searching there is a link here where the OAuth proxy is available. It's the point number 5. Let me download that. Now I'm going to the API platform. Let me move into the API proxy. So first we'll complete the part 1 and then we'll move forward, right? So let me again, I'm using the same wizard like used the last time. I'm uploading the proxy bundle. I'm using the whatever the bundle I just downloaded. It's doing the verification point. Now it's based on the bundle, it's generating the proxy on the RPG Edge platform. So now if you notice, by default, this is the base path. There's no need of the target endpoint. Here's the sample one. Let me deploy into the same environment where my previous proxy was there, test. So now it's available. This endpoint is available, but to access the endpoint, now we need the API key and the secret, because internally it's expecting the API key and the secret. And the way we can check is, if you go into this, there are two policies which already been there. This proxy has for the access token as well as the refresh token. In this lab, or the client credential grant types doesn't support the refresh access token. It's only the access token base. But this one, you can use it for the other grant types, the other three ones. So if you notice here, it uses the information with the grant type, with the API key and the secrets on that, and then it will generate the token. So this is the part one. So I request everyone to download the auth zip file and then upload it into the as a proxy bundle on that side. I will be on mute now for 2 or 3 minutes so that you people can complete it. Right. I'm sure some of you may have gone into the next steps as well, which is fine. All the steps have been detailed pretty well, so just follow the steps. So what we have done now is we have completed the part one. So the part one means we have created another proxy, which is the auth2 proxy, which can generate auth2 token. Now coming back to our business API, which is in this case is our hipster proxy, which we are using for the accessing the backend service. So now we need to enforce this proxy has the token verification policies on that. So let's click on this proxy. Go into the develop tab. So now if you notice here, as part of this bundle, the spike arrest policy is displaying here. So now let's add the proxy, our token verification. So if you notice on the security side, there are many policies are available, and there are more than 15 plus policies, auth2, JOT, SAML, JWS. So all those policies are there which are out of the box. And these are the XML threat and the JSON threat protection, which I mentioned earlier. Now let's click on the auth v2.0 because we are implementing the verified token steps. So let me add that. And if you notice here, the default configuration of this policy is verify access token. If you see here, the first policy is the spike arrest and then the verify access token. Normally this is the recommended way, but just for our demonstration purpose, because we really don't need the spike arrest. So what I am doing here is, if you look into the endpoint default, it's one followed by other. Let me drag and drop. So now the old V2.0 policies become the first one. Let me save as a new revision. So as a best practice, in the labs, it's the same revision, but as a best practice, that may be done. Whenever you make any modifications, save them as a new revision. So now I'm deploying onto the test environment after making these changes. Okay, so the revision 2 has been deployed onto the environment test. Let me go into the trace. Let me start it. Let me add the products, resource path, otherwise. So if you notice here, the very first request, it's saying there is a token execution error, right? And it's not even going to the spike error. So the very first policy which is getting failed or is not getting fulfilled, the requirement, it move into the error path scenario, right? And if you look at it, what really the error message is going on, it's saying invalid access token, and it's returning back the 401. And again, it's giving the time taken by this policy, right, or this request. So let me make the same thing. Last time we were making this request and we got the successful of the spike arrest. I'm making the request from the Postman, which is the external tool. You can use the Postman or the curl. Let me send the request here. Again, it's the same thing. It's saying, okay, API, I need the token. You're getting the invalid access token. So it's a 401 unauthorized. So that's the default message which is being added by the APG Edge platform. So this is the second part, number 2. Please follow that steps. I will be again mute for 3 or 4 minutes, and then I will rejoin you back. In case if you are facing any issues, please raise those points into the Q&A. My colleagues will help you out. I'm hoping you are able to complete the part 2. So let's move into now the part 3. So the part 3 means now we know there are 2 endpoints, and as a app, I want to consume my business API, but I'm not able to do it because the token is not available. So now that means as a developer, I need to get the API key and the secret, and before that this can be generated, first we need to create the API product. So we have created the 2 API proxy. Now the whole significance of the API product in APAC platform is to provide an abstraction where the same API proxy can be part of the multiple API product. So these different API products can be consumed by the different apps. So let's move into the part 3. So as part of the part 3 now, we'll create an API product for having the API proxy there, and then we will create an app so that we can get the API key and the secret. And for that purpose, we now need to move into the publish tab. So if you notice here, as part of the publish, so the development means the development of the API proxy, connectivity with the backend service, implementing or the configuring required functionalities there. Now when we are going to publish it, this API proxy as an API product, so we come under the publishing tab. So let me go into the API products. So we'll create now a new API product. We will give this name, let's say the hipsters, because we are using this one. Let me use the same as the display name. I'm creating on this one. The key point here is what should be the accessibility of this API product. Again, you may want to have it public so that it's available to everyone. You may only want to have some specific, your partners, you can have the different access mechanisms for that. The key point for any product, we need the API proxy or for which this part of it. So let me find out where my API proxy is. This one, let me add that. Right. So this API proxy is being added. Let me save it. So with that, now we have created an API product having that business API proxy. You can have as many API proxy as you think within a single API product. Now the second point is, now we need to create an app. So this app, what really signify is having the API key and the secret, which is corresponding to the real mobile app. That's what it means here. So this becomes sort of the reference within the APAC platform. Okay, this API key and the secret has been given to, so let me, to this app. So let me give this hipster app. I'm using the developer. In your lab, I have already the developers. In case if it's a new org, there may not be a developer. There are steps are there. Basically under the developers, you can go and create a developer. So I use that. Now when you give these credentials, right, you can mention the point, okay, this API key is valid for up to this date or up to these many durations, right, or never. So all those options are available. So let me say the never for the time being. And definitely then we need to say, okay, this app can access which product, right? So let's add that product. So this automatic approved part of this one. So let me now create the app. So now if you notice, this gives me the detail, okay, this app was being created at this time by this developer. If somebody wants to have the future check and it's already approved, that means this app can make the request. You can also have the manual approval where somebody has to go and manually approve it. And these are the API key and the secret. Let me bring up that, right? Because we will be using this API key and the secret now to get the token. So this is the part 3. Once you have the app, with the API key and the secret. So that will complete the part 3, and then we'll move into the part 4 where we'll use this API key and the secret to access our business services. So I will go on mute again for 3 to 4 minutes, and then we'll rejoin you guys back. In case if you have any queries, any questions, please feel free to raise them in the Q&A chat. My colleagues will help you out. In case if you people have done it, please follow the steps for the part 4 as well. Steps have been pretty detailed there. Right. I'm hoping we all have done the part 3, right? So just to summarize what we have done in this lab, right? First, we have created an auth endpoint which can generate the token. So that's a separate proxy, auth proxy, right? That will help to generate the token. The second one, our business API, which protects the business backend service, Hipster in our case, we have enforced the token verification policy on that. So it requires a valid token before the request can go forward. So that's the second. The API proxy, the business API proxy, we have created an API product which can be consumed by an app or more than one app. And once we have created an app, we got the API key and the secret, right? So those 3 things are done. So basically we have built the foundation. And in the part 4 now, we are going to obtain the token first from the auth proxy, and then we'll use that token to access the business service, and we'll see if all this flow goes fine. Now, till now, whatever the API proxy we were making the request, we were using the HTTP verb get, and that's what's possible in this API Edge. If you notice here under the API proxy and in the trace tool. But for token generation, we need a post request. We are creating a token. We are generating a token. We are not retrieving the data, right? So from that purpose, I'm using the Postman or any other tool like the curl can be used just to demonstrate how the things would be happening when I will be making the request. I'm opening a proxy window as well as let me open the app so that I can get the API key and the secret. This is our trace window, so let me access on that. Let me start it. This will give me the API key and the secret. So when we're making the request on the token endpoint, the HTTP verb has to be post. I hope you people are able to see the screen. It has to be the post. This is our standard URL, auth and the client credentials. After that, we need to add the access token as a resource path. And this access token required a query param. So that's the reason if you see the query param here, grant underscore type equal to client underscore credentials. So we need to use this flow on that side. So I had this earlier app, so I'm removing that because I will get the new API key, the one which I have generated. So let me clear it out. Okay. With that, I'm going to the apps now. Our app name is Hipster. Let me see the API key. Okay, the Postman has the functionality where you can use the basic auth. So it gives you the multiple in the authorization, right? No basic auth. So I'm using the basic auth and putting up the API key. And if I go into this one, the secret, and with that, when I say the update request, it goes and updates the basic value on the authorization header. In case if you're not using the Postman, the other point is you will need to make the base 64 encoding of the API key and the secret. With that, we can make the, as part of the, if you're using the curl command, we can use the basic header on that side. Now, with this information now, let me make a request. This is our auth proxy. So So let me make this request. So I got this response from the APGL platform, right, for the token generation. Definitely, if you change the API key and the secret, right, one of the alphabet, this won't work, and it will throw the error. So if you notice here, this APG platform is sending back lots of information about the access token. This is our access token which we are interested. It's also giving the information for which API key, when this access token is being issued, what's the type of the token. It's a bearer token, right? For which developer, which organization name. So it has lots of information on that side. And another important one is when it's going to expire, what is the TTL, time to live for this token. The enterprise, if you want to display only subset of the information, that's possible. This is the default information. We can reduce it. We can configure it, what really the information we want to pass on to the app, right? So that's very much possible. So now I got this token. What I will do now is with this token, we need to now make the request. Okay, so we were in this trace window. If you notice here, we got this was the request for response what we received, right? Let me move into another proxy now, our business proxy. Because now we'll be making the request on that with the right token. Again, put me into the trace, right? Let me now, this is our hipster products API. We were sending this request when we get the token, invalid access token earlier, right? On this one. So let's see if I remove this one, and if I send this information again, I will get the same thing 401 because the information is not there. Now as part of this one, let me send the right token, what we just obtained in the previous call, and let me make a request. If you notice here in the trace window, there would be two requests. This was the first one when I sent with the without token or the older token, and this is the next one. So if you notice here, the token verification got passed. It's a valid token. Then it has verified, okay, it's within the spike arrest policy. Then it made a request to the backend service. It got the response, and then the response has come back all the way to the consumer. So in this process, we obtain the token first, and then we have the request of the business service, right? So I use the postman for the API key and the secret and convert into the postman. If you are using the curl command, we can use the base history for encode, which is the standard one. For the demonstration purpose, you can use this one. You go it here. Again, we need to get the API key. Right? You use the colon on that, and then you use the secret. And if you know, this will give you the base history for encoded value. You need to pass on this part of the authorization header. Right? The key point to note here is when I'm sending the token as part of the authorization header, it's a bearer. So I am prefixing it with the bearer. But when I'm generating the token, the OAuth protocol recommends this is the base history for encoded value of the API key secret, and this has to be done the basic as the prefix. Don't mix it up, otherwise this won't work. Right? So first, you got the API key and the secret, use that as the base 64 encoded, make a request with the post command, and you need to add the grant type as a query param with the right resource path. Right? Otherwise, you may not get the right response. And then this will help you to get the access token. So I will be again mute for 5 minutes. Please follow the steps. In case if you are stuck, please let us know by the Q&A. If some of the folks who have completed the whole labs, I will encourage you to look into the different combination of permutations of that and see what sort of the response you are getting. That will help further understanding of this concept. Thanks. Uh, I think there was some audio issues. Is this better now? Yes, I guess so. Okay. So one of the, after the API, after we have enforced the API protections and across the APIs, for an enterprise, it may happen once the number of proxies are 50, which is common case now. How they ensure each and every proxy had the right security mechanism has been enforced or not. So for that purpose, within the APG platform, we have developed API security dashboard, which provides the information of different aspects of the security at the runtime as well as the design time both. This API security dashboard may not be available in your trial account, but for the license account, this option would be available. So as an API team, you can analyze whether all the traffic is coming over HTTPS or HTTP. Most of the enterprises are setting this as a guideline, or basically it's a recommendation where the traffic they want to the HTTPS. And if any traffic is coming non-HTTPS, it goes through the approval process or under the analysis process, why it is so. Then for each and every, if there is a non-HTTPS traffic, then this dashboard lets you know which proxy has the non-HTTPS traffic or how much is the total traffic is there. Now for each of these proxies, which targets they are hitting. So this gives you the information about the runtime, what type of the traffic is, whether it's a secure traffic, it's a non-secure traffic, and if it's a non-HTTPS, then which proxy has this behavior or this functionality, and if something needs to be done on that case or not. So if you notice here on the runtime side, this also gives you the information in terms of the traffic. You have the options, which environment, which region, if it's a multi-region, right? And now for each of the traffic, it will give you the information how much traffic is coming up. So if I can see from this dashboard, these are the two proxies which are getting the maximum traffic. What's the delta change? Is there any non-HTTPS traffic? And how many apps are there? So it gives me again a runtime perspective who are consuming my API. Now for the design time, let me go into the real tool and let me show you how at the design time this looks like. For that, I need to log into my another org where this has been enabled, this dashboard. So if I go into the admin, under the analyze, so if you notice here, all the other tools start is being available here, and one of this one is the security reporting. You may be noticing the another one is the API monitoring, and both of these tools, these options won't be there in the trial one. So let me click on the security reporting now. This gives you the overview like we have seen in the slides across the different timelines. Again, it's the runtime, what we have seen in the slides. And this is another important point which I really want to highlight, where I've seen many people are doing the manual review and they are trying to find out whether all the policies are there or not. This dashboard makes that things very transparent to anyone who is doing the review. So if you notice here, there are multiple API proxies, and it gives you the information whether it has a traffic management policies or not, whether it has the security policies or not, and whether it has any extension policies. And the shared flow is one another concept within the APG platform, very, very popular one, where you use set of policy into a one shared flow, which can be reused across multiple proxies. So it's a reusability perspective. And now whether this API proxy is available on the non-HTTPS or HTTPS or not. Now, if I want to look into further, so let me click on the Hello V1. This gives me the further details. If you notice, this gives me what type of, okay, so this has the one shared flow protection SF-V1, and within that protection, right, it has the quota policy, it has the spike arrest policy, it has the verify access token policy. So in that perspective, it again gives the information, okay, my these proxies are secure. In case, if I go into my first proxy, it has none of that. And if I click on it, it says there's only extension policies have been configured, no traffic, no secure policies, which means it's a red sign for me as a reviewer to analyze that. Right? So this is one of the tools on the API security dashboard. I'm looking at the Q&A, and I have seen there are some requests which are coming on the API monitoring perspective as well. So I will just utilize this time to highlight that point as well. Within the APG platform, there are two distinct points. One is the, if you notice here, under the API metrics, which is the API proxy performance, this is what we say as the analytics. How my APIs have been doing in terms of the traffic, in terms of the response time, across those multiple dimensions. How many are successful, error code, this is under the analytics. But the another key dimensions, what is coming up is how many APIs are these being available, are they accessible? So for that purpose, the API monitoring comes into the picture. So this organization, this doesn't have the data, otherwise it will highlight how much on the different prod, region, proxy, what are the proxies are there. And if you want to further investigate, let's say some proxy is returning high, either the response time or the high error rate, you go and click on those proxies and you can get the data either on the status code or the latency basis. So I just thought to utilize this time just to highlight on that point. With that, we have come to the end of the today's lab. So just to highlight, right, what we have done protection and then implemented the auth to endpoint for generating the token and then using that token for accessing the business service. I hope you people have enjoyed it. I understand it's in terms of the today's world, it's I wish all of you to be safe. Please let us know how do you find this lab. We are welcome all the feedback, what really you want to hear in the next time so that we can take up that topic as well. Some links which we really recommend, these are the highly rated links and they're loved by the developers on the documentation sites, certifications, course and training, community, the 4-minute video for developers, which is just in a 4-minute, it will explain the concept. I encourage all of you to go through these resources and learn the APG platform. Thanks a lot. Back to you, Felicia.